This synthesis presentation will focus on Morgan, Frisco, Farkas, and Hibbel's article, A Propensity Score Matching Analysis of the Effects of Special Education Services. Propensity score matching is a statistical matching technique that can be used to estimate the effect of a treatment, policy, or other intervention by accounting for the covariates that predict receiving the treatment. It is implemented in an attempt to remove biases. With propensity score matching, the researcher is able to model random selection. Propensity score matching is used in research to eliminate or reduce biases when the treatments cannot be randomized. Propensity score matching also balances covariates. OLS regression cannot always control for selection bias. If the covariate distribution between the treatment and control groups substantially differ, the assumption of a linear-nonlinear functional form will not hold up. This article used propensity score matching to explore the learning and behavior of children who did and did not receive special education services, but who displayed similar propensities to receive these services. Similar propensities were indicated by measures of their health and well-being, family experiences, child care experiences prior to school age, socioeconomic background, prior learning and behavior, and quality of school experiences. The study specifically examined reading skills, math skills, learning-related behaviors, externalizing problem behaviors, and internalizing problem behaviors. The authors used data from the Early Childhood Longitudinal Study Kindergarten Class of 1998-1999, abbreviated ECLSK. This is a large-scale, longitudinal, and nationally representative sample of U.S. school children. 2 samples of children were used. The first was used to measure the propensity to receive special education services, being eligible only if the student participated in ECLSK in the springs of 2002 and 2004, and have data on whether they were receiving special education services by spring of 2002. This second sample was used to estimate the effects of special education services on children's learning and behavior, only eligible if there was complete data on each measure of learning and behavior. ECLSK reading and math test scores were used, as well as teacher-completed social rating scales. The ECLSK reading test was made up of field-tested items. The items also displayed acceptable item-level statistics, a good fit with likelihood item response theory parameters, and no differential item functioning across gender or race. The math test was developed by a multi-step panel review process and also implemented item response theory parameters. The teacher social rating scales had construct validity supported by correlational and factor analyses, and used a frequency scale to rate behaviors. The study used several dependent variables to analyze the test scores, as well as gains among each test within each area studied. The treatment variable were those students who participated in ECLSK in the springs of 2002 and 2004 and were receiving special education services in the spring of 2002. Control variables functioned as predictors of special education placement. Control variables included gender due to the fact that boys are 2 to 3 times more likely to be identified for special education services. Other variables include family and school socioeconomic status, parents' marital status, participation in the Head Start program, the student's birth weight, the mother's age at the student's birth, and non-parental child care before kindergarten. In previous studies of special education services, these were all variables that had been identified as predictors of special education placement. The authors of the study chose to implement the quasi-experimental approach of propensity score matching as a way to approximate results that would preferably be obtained through randomized control trials. Due to criteria for eligibility, special education placement cannot be randomized. The authors thought it best to also account for instances of students who could qualify for special education services but have not yet been identified and tested. T-tests were used to determine whether the mean differences in the learning and behavior of children receiving or not receiving special education services were statistically significant. These results were considered a benchmark for the results obtained through propensity score matching. OLS regression was used to estimate the average treatment effect of special education services. Covariates used as control variables in OLS regression models are the same covariates used in models estimating children's propensity to receive special education services. The results of the OLS regression were also considered a benchmark as a comparison to the results obtained through propensity score matching techniques. As previously stated, propensity score matching was used to allow for contrast of the learning and behavior of children who did and did not receive special education services, but who had the same or nearly the same probability of receiving such services. Propensity score matching yields an average treatment effect for the treated, abbreviated ATT, which is considered a better indicator of whether to continue policies or programs that target a specific group of interest than the population-wide average treatment effect obtained using OLS regression methods. The Logit model was also used to predict children's propensity to receive special education services. Propensity score matching was chosen for this particular study to allow for contrast of the learning and behaviors of children who did and did not receive special education services, but who had the same or nearly the same probability of receiving special education services. The study considered a wide range of observed background characteristics, and the treatment group was not able to be randomized and exclude biases due to eligibility criteria. The study was separated into two stages. Stage 1 entailed the use of logistic regression model to calculate all respondents' propensity for experiencing special education services. Stage 2 involved the use of estimated propensity scores obtained in the previous stage to match children who were and were not placed in special education. 3 matching methods were used to guard against bias. Stratification matching uses all treatment and control cases. The full range of sample members' propensity scores are divided into propensity score strata, which includes treatment and control cases with the same or nearly the same propensities for receiving the treatment. Nearest neighbor matching uses estimated propensity scores to pair cases in the control and treatment groups on the basis of their likelihood of experiencing the treatment. Control cases not matched to a treatment case were excluded. Kernel matching was used to calculate propensity scores to match individual cases in the treatment group to a weighted mean of control cases. Control cases receive weights based on the distance between their propensity score and the propensity score of the treatment case by which it was matched. Simple mean differences in OLS regression were both chosen as benchmarks for propensity score matching. Propensity score matching was used as a way to reduce selection bias since there are several control variables that reflect bias among identification of students for special education placement. Results for special education effects on reading skills indicate children receiving special education services scored about 1 standard deviation lower on the reading test in spring 2004 than those children not receiving such services. Children who received special education services also displayed 2.7 points more in skills gain between the springs of 2002 and 2004 than children who did not receive services. Matched on propensity to receive special education services, children who received services displayed neither greater reading skills in 2004 nor greater gains in their reading skills between 2002 and 2004 when compared to closely matched peers who did not receive services. Special education effects on math skills reveal simple mean differences indicating that in 2004, children who received special education services scored 16.5 points lower on the math test than children not placed. Adjusting for the model's covariates reduces special education's negative effect from 16.4 to 3.5 points. Matched on propensity for special education placement, negative effects of special education are reduced to statistically non-significant. Teacher ratings on behavior indicate special education students are less task-focused. However, over time, special education students did begin to engage in learning-related behaviors with increasing frequency as opposed to those who did not receive services. Regression coefficients show that special education has no statistically significant effects on the frequency of children's externalizing problem behaviors after controlling for covariates. Receipt of special education services does not decrease the frequency of children's internalizing problem behaviors. For reading skills, though remaining statistically significant, the results indicate that statistically controlling for differences in children's backgrounds substantially reduces special education's negative effects from negative 22.3 to negative 6.6 points. Adjusting math scores for the model's covariates results in a substantial reduction in special education's negative effects, causing the points to move from 16.4 to 3.5. Overall, the study found that special education services had negative or statistically non-significant effects on young children's reading and math skills. Regardless of a child's propensity to receive special education services, receipt of services resulted in no statistically significant change in the student's reading or math skills. Special education had negative or statistically non-significant effects on most children's externalizing or internalizing problem behaviors. Receipt of special education services had positive predicated effects on children's learning-related behaviors. The study saw that special education improved the learning-related behaviors of the children who were most likely to receive services. The use of propensity score matching was most appropriate for this research since randomized grouping was not available. Considering there are trends in the covariates for students who are placed in special education, using only those who are already placed in special education was not an accurate representation for a treatment group. Identifying and considering the covariates that can affect special education placement addresses causal inference. By identifying and addressing covariates, this study accounts for issues in causality. However, I do believe comparing the gains are more appropriate than comparing the reading and math test scores, since students who receive special education services are more likely to score lower than those who do not receive special education services.